लो बच्चों, लेट्स रीड द क्वेश्चन। तो क्वेश्चन में गिवन है कि इन ए परफेक्टली इलास्टिक कोलिशन द रिलेटिव वेलोसिटी ऑफ रिसेशन आफ्टर द कोलिशन इक्वल्स द रिलेटिव वेलोसिटी ऑफ अप्रोच बिफोर कोलिशन। राइट, रिलेटिव वेलोसिटी ऑफ रिसेशन मींस कि कितना वेलोसिटी से कोलिशन के बाद वो दोनों पार्टिकल सेपरेट हो रहे हैं। राइट, तो इस क्वेश्चन में हमारा जो की कॉन्सेप्ट होगा, की कॉन्सेप्ट वो है कॉन्सेप्ट ऑफ कोएफिशिएंट of restitution that we denote by E, right? Now let's say कि दोनों masses of m1 and m2 are moving with initial velocity u1 and u2, right? So to collide each other, u1 must be greater than u2, right? So at a point they will collide with each other. So let's say at this point they had collided, right? Then the final velocity of the mass m1 will be v1, and let's say the final velocity of the mass m2 is v2, right? So we know that in case of perfectly elastic collision, there is no change in kinetic energy before and after the collision, right? So let's see that what is the coefficient of restitution. So coefficient of restitution, that is E is equals to velocity of recession by velocity of approach, right? So इस केस में velocity of recession मतलब velocity of separation कितना होगा? So this will be v2 minus v1, right? As the two masses are moving with v1 and v2. Now the velocity of approach will be u1 minus u2, क्योंकि u1 और u2 वेलोसिटी से ये दोनों पार्टिकल आ रहा है आपस के, और द u1 is greater than u2 so that the collision will happen, right? Now for perfectly elastic collision, E, that is the coefficient of restitution, is equals to 1, right? So that means v2 minus v1 by u1 minus u2, which is a expression of E, is equals to 1, right? So you can say that v2 minus v1 is equals to u1 minus u2, और v2 minus v2 क्या है? This is actually the relative velocity of recession, और u1 minus u2 क्या है? This is the relative velocity of approach, that is before collision. Hence, in perfectly elastic collision, the relative velocity of recession after the collision equals the relative velocity of approach before collision, right? So hope you understand it. Best of luck.